Okay. So Bismillahirrahmanirrahim. We start with the Umul Kitab Al-Fatihah. أعوذ من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. Okay guys, so today we will try to continue geothermal energy. We already covered last week. Just the matter, just to scan through whichever important remarks regarding the geothermal energy, because some of it we already cover from the previous meeting, from the previous class. Okay, so it always goes to the situation of if you have the question, then you may ask verbally directly, or you may chat, you may write in your chat box, whichever question, and so we try to respond on it. Or else we just wait at the end of the class to raise your question, and so we'll answer your question accordingly. Okay, there should be no problem, whichever you are convenient with. Okay, so basically, as I mentioned, geothermal energy, which is not that popular in Malaysia, in the form of the primary source of energy, it more towards to the so-called tourism attraction, I would say, hot spring and everything. So, but then it's there. Then we need to know it's a part of how it's work, how it can be manipulated, or how to convert it in the form of the technical and knowledge-wise. If not, we know that's the source of hot water or geothermal energy, but then we do not know or appreciate what is the thing all about, especially how to harvest it to become the source of energy. Okay. Okay. So just keep this one, just to give you the idea, the potential of the geothermal energy. But this one is particularly for the others country. Okay. It's a quite huge in the form of the sources, because the moment your so-called area have that kind of source of geothermal energy, then it should be more or less the same in terms of the production, right? So you can see this one. But the others, you can see, it can be fluctuated or based on the market demand and supply and demand purposes. Okay, so that's the thing. Because normally for the geothermal, it seems like the more you harvest the energy, the more you get, or else provided with the location you have been harvested, which is if they have the source, then you can have the source of energy. If not, then you don't have any kind of sources related to the geothermal energy. All right, so this is the advantages of the geothermal. Okay, knowing that we are producing based on the hot water to become a steam, so that automatically or should be directly in your mind is a very low CO2 emission, because there's no any related with the burning activity, right? And then cost. Cost is quite subjective. It depends how the system is and how the complexity of your system. Okay. So this is the thing. But I think the cost that they try to mention is that the cost comparatively to harvest the energy based on the other type of renewable energy. Okay, for example, maybe this considerably low cost, perhaps due to the if it compare to the hydro energy, which is need to produce the dam and everything, or maybe the wind energy itself need to build the wind turbine with a certain height or certain elevation. So maybe they claim relatively regards to the renewable energy. Okay, so what's that? So try to minimize this one. All right. So, okay, heat from Earth center. Okay, so that's the idea lah. So that's the idea. We try to drill our surface of Earth towards to the Earth center and gain the heat and then from that particular condition or that high temperature may transform or convert the water, which is we will try to flow the water underneath towards the earth center, and then it become the form of change from the form of water to become the steam or high steam and everything. And again, as you already learned from the power plant subject, that steam will rotate the turbine and etc. to convert the energy. Okay, so that's the thing. Okay, continuous heat from core. Okay, mini heat, flood, volcanic activity, transport hot material, hydrological convection from high temperature geothermal system, shallow depth of 500 to 3000 meters. Okay, so Earth's core maintain temperature in excess of 5000 Celsius. Just imagine the free source of high temperature. Okay, just the metal you need to drill it towards the center of Earth lah. That's one thing. Secondly, the technology can sustain that particular condition. That's the second thing. But the best part, if you do not go for this kind of range of temperature, then you can go to what is your targeted temperature. Maybe it can just up to the 500 meter underneath the center to Earth to get the high temperature. Okay, so it depends. It's not necessarily we try to drill from the surface until the center of Earth to get that 5000 degrees C. It depends. What is your required temperature? Okay, so let's say if you go for, let's say, 100 meter down Earth should be insufficient, then you may go until that far and not that particular detail until the really center of Earth. Okay. Okay, so basically this is the thing, this is the condition. Okay. Okay, so what we have staying here, mid-ocean range, okay, fracture ozone offset range, continental volcanic chain. Okay, so this is the forestry, continental rising magma, heating melting, oceanic lithosphere, subduction. Okay, so this is the temperature 2000 something towards the center of Earth, heat and melting, everything. Okay, so that's the first dynamic look like. Yeah, so depends how long you want to drill your system, either 100 meter inside, 500 meter, depends the targeted temperature you want to harvest. Okay? But normally, as long you can go for the case of steam from the water to become the steam, and that it can sustain that heat, and then it should be normal, because we need to consider as well the losses. It can be the very net in that particular temperature downside here, but then during the traveling going upward to deliver to the power plant station, it might be losses somehow in the pipeline, so that we need to consider the losses as well. So because at the end of the delivery, it should be still sufficient to produce the steam power plant in a form of that substance. Okay, so this is the thing that's mentioned according to your depth of your drilling. Okay, it can be tabulated in a form of the Earth's temperature gradient. Okay, so from the I mean, this one is temperature, this one is the depth of your radius. Okay, so the deeper you are going to this one, and then the higher temperature you begin. So normally depends, as I mentioned, some of the parts they may go only for the area of the mantle only, cannot go to the outer core and inner core, because the mantle also is still sufficient to get in the range of the 2000 to 3000 Kelvin, just to provide the appropriate temperature for their production or for their system to work. It depends. Okay, so but then by having this kind of condition, then you can get the idea what it's all about in terms of the deeper of your drilling in your earth, and then the temperature that you gain, okay, from that kind of activity. Okay, after some time, it quite a plateau over here, somewhere in the range of this one. Okay, so maybe this one is more with the conversion, the conversion before they try to go the the range, the obvious range from this one. Okay. So that's the thing. So maybe this one, the moment it able to penetrate the layer, and then they can go significantly to increase the temperature by having the increment of the radius. Okay, so that's the thing. So this one is imagine from zero. So just imagine the core is like from zero, and then the radius greater and greater along the way. Okay, so that's why we start from this one zero. This one is 7,000 kilometer. Okay, so this is the concentric, this Earth core. Okay, and then okay, so try to analyze this one. All right, better. What's the title? Geothermal site schematic. Okay, geothermal site schematic. So, so say this is the term, that been used to classify the phenomena that happen relates to the geothermal condition, I would say, okay, or geothermal phenomena. For example, what we are more familiar is that this one, hot spring, and hot spring. And so if you go to the hot spring, then you can try to imagine, okay, the F, okay, you can see F, okay, this one. So we provide schematic cross section to show the three essential characteristics of a geothermal site: fire, okay, fracture limestone with solution cavities. Okay, so that's one thing. Fire, okay, fire, this one is there underneath us, okay, water table, everything, and then there's the flow, okay. And a heat source, crystalline granite, okay. Steam and hot water escape naturally through fault F in the cap rock, forming fumaroles, okay. Geyser or hot spring, hot spring, hot water only. Okay, geyser, hot water and steam, okay, right? Okay, so if you go to the hot spring, it should be expected to have only the water, hot water only. Okay, but if you go to the geyser, it can be a package lah, kan, package. Hot water plus the so-called steam, okay, steam escape from the rock inside that particular area. Okay, the aquifer is confined with the benefic type rock, impermeable crystalline rock, prevent downward loss of water from the aquifer. So that's the condition. Okay, or steam well. So they try to suck this steam and then go to their plant and then convert it to the energy. Okay, but for the hot spring, for Malaysia, normally we go for the tourism attraction. Okay, tourism attraction, then you can get to get the hot water and boil your egg, something like that, as a part of the recreational with the family activity. So that's the thing, right? Okay. Geyser di Malaysia kita ada geyser. Ada ke siapa pernah pergi mana-mana tourism attraction di Malaysia yang ada geyser juga? Ada that kind of steam burst from that surface of area? Ada tak? Siapa yang baru-baru bercuti ni kan? Ada tak? Ada. Okay, so but then if you see that kind of phenomenon, it should be not the hot spring. So it should be the geyser, which is including the case of this steam as well. Okay, so this one, geyser, hot water, and steam. So you can see, obviously the steam is come out from the land, which is escaped from the rock inside that particular area. Okay, and you just imagine, guys. So this kind of situation normally it will be the case of underneath the system, right? Because in the surface, on the top surface, we just go for the very normal condition, but actually inside or underneath the land, then based on the rainfall and then the container of the water, okay, and then also the case of the heat from the earth will create that kind of situation. Okay, F fault means that steam and hot water escape naturally through fault in the cap rock forming from murals, okay, geyser and everything. So meaning to say, this F thing happen naturally. Okay, there's no any people try to do the drilling and everything, just come naturally, and then the escaping aqua fire from this confined space and then penetrate all over the maybe the hole through the rock, and then they go for this kind of phenomenon. Okay, okay. So that's the thing. So if the hot spring only the water, tomorrow only the steam, and geyser is package water and also the steam. Okay, so the rest there's nothing much different, but just to imagine that if we can have this kind of option, so it trigger us, we have the potential to have also the hot source from the underneath of our earth, right? Because it shows that we are having this hot spring naturally. It's just a matter it worth or not for us to invest that particular source to become our secondary of source of energy. Okay? It depends. Okay, so because normally this kind of thing maybe in the area in the with the rock and the mountain and everything, but then the power plant, the best way, the nearest the better, right? So but then it also consider the condition of the how to build the condition, the safety of the environment as well. So that's why big things we need to consider before we go for the implementation for this kind of renewable energy. Okay guys, quite interesting. So lepas ni kalau nampak tu, nampak geyser, kan, geyser, then you guys boleh tahu lah, pernah belajar lah, RE, then the combination of the steam and also hot water, right? Okay, so this maybe the geyser others country lah, not Malaysia lah, so nampak lah ni. Kalau macam se pergi ni pun se pun panik ni kan. Tengok ni akan nak gempa bumi ke apa kan. Ni akan nak apa kan. Tapi tak apalah. Maksudnya that's one of the phenomena which is related to the geothermal, which is producing the hot water and steam simultaneously. Okay. So this is the thing. So kalau only that steam, what we call? Ingat lagi. Kalau steam saja yang keluar. Formural lah. Formural this one. Dia keluar steam aja. Ni formural. This one. Formular di sini. Tadi formular steam only. Okay. And then okay, formular, okay, so this is the thing. So this phenomena is happen. Jangan ingat macam apa ada raksasa keluar daripada gunung ke kan. Tak ada lah. So kita go for the basic fundamental study at first. If you know that particular area have that kind of situation, ada apa, ada gunung berapi ke mungkin nearby or somewhere, and that it can be most possible to get that kind of situation, either the glacier, mineral, and also the hot spring. Okay, kan macam apa magic kan keluar. Okay, so this is the location global. I mean, so we just to share. I'm sorry. Sorry. Okay, global geothermal site. Okay, so just so the enlarge is fine. So let's see together this one, guys, and see where is the measure. Active volcano. Okay, so the maybe the dotted black active. Yeah, active. Okay, so it can be somewhere at the sea and some of it on land. Okay. That's the geometric graph. Okay, so geothermal power plant. So this one, this block, this big black dot, geothermal power plant. If you can see, normally and mostly nearby to the sea, kan? Nearby to the sea. So this one also the sea, okay, nearby to the sea, okay. And then potential of using geothermal. Okay, so the orange in color, so the site that have the potential to have the geothermal energy. Okay, so which is Malaysia not including at all of any. Okay, we do not have the active volcano, and of course we do not have the geothermal power plant, and also we do not in the situation have the potential of producing the geothermal energy. Okay? So because we are somewhere over there, kan. So that's why yeah, our friend, our neighbor guys, kan, yang this one kan, this Indonesian punya parts ni, they been uh, in the case of active volcano, kan. So they are the region of that. So yeah, I'm not sure whether they are trying to, but based on our reference, even they have the active volcano, but they do not have the power plant, I mean geothermal power plant for that. Okay. So depends on their uh, decision, but then that's the equation. So we are, guys, so we are very blessed in our country. Yeah. So we do not, I think, in the range of the volcano activities, kan, volcanoes punya area, gunung berapi kita clear, kan, nearby je kan, sebelah-sebelah saja kan, di bawah sini sikit, sini sikit, sini sikit kan. So, yalah. So we need to be so-called pray for that lah. So should be Malaysia in a good bless lah at all time, insyaAllah. But then we do not have that kind of concern. If you can see, it's Australia itself. They also seems like a very clear in terms of the geothermal parts, in terms of the volcano, okay, and the power plant. So maybe they also have a good condition to plan other start of renewable energy. Okay, so maybe this the one of the factor why we are not going into that part, because geographically we also not consider it's a part of the potential area or location to produce the geothermal energy based on this kind of information. Okay, and then this one so okay, so hold on. Tectonic plate movement. Okay, so tectonic plate movement. Okay, so you can see this one. Major high enthalpy geothermal. Okay, we just go for that kind of high enthalpy geothermal energy producing area, which is orange in color. Okay, so we can see this one, more or less as I mentioned, nearby to the sea, yeah, which is this one, in the middle of the sea. Okay, so this one is nearby on the sea. Yeah, so this one, and fortunately, Malaysia not include in the case of the movement of the tectonic. Tectonic means that the movement underneath of our land, which is may occur maybe the different of the landscape, or maybe might affect to the wave and tidal condition. So it depends on the movement at the groundwork of our land, okay, which is our country. We are not including that kind of situation. Okay, so this one, so the escape this one, all right? Extracting geothermal energy. Okay, I think this one is as I mentioned, we already cover briefly in the previous class, but then so just go very quick, just to recap certain things related to the extracting geothermal energy. Okay, guys, so this borehole XC exchanger. Okay, if you guys can see this one, the depth. The depth we need to, I would say, drill to get the expected heat. Okay, hydrothermal system, hot dry rock. Okay, everything. 10 degree heating with heat pump, heating without heat pump, process heat and power. So on your right hand side, refer to the case of what is your expected outcome by having this kind of drilling activity. If you want to go for this kind of process heat and power, then you need to drill a bit deeper, okay, to get that kind of range of temperature. Okay, if not, depends. Okay, and also they have a certain mechanism or system. Okay, so depends. Okay, depends. borehole exchanger, okay, the water circulator over here. Yes, in the range of the 0 to 3 kilometer. Okay, but when we go for exit on that, then we can get the higher temperature. I think that's a logic and normal. When we go deeper, then we go higher temperature of it. So this one, so just skip, just the conversion of the pressure and temperature. Some of the people may choose the Pascal, Newton, megapascal, and etc. But some of the people may use the Celsius, Fahrenheit, and Kelvin. Depends. Okay, so depends. Okay. So dry steam extract from natural reservoir. Okay, so this one in the range of 180 to 225 degrees C, okay, 4 megapascal. Okay. Um, And then this one is the rate, kilometer per hour. Okay, it's the rate. Steam is used to drive the turbo generator. Steam is condensed and proposed back into the ground to achieve 1 kilowatt hour per 6.5 kilogram of steam. Okay, so it depends lah. So depend how the work you want to deal with to produce your steam condition. Okay? Because it might give you the different range of the power output if you go in detail in terms of the production. So this is the thing, maybe most typical style of operating the geothermal. Okay, so you can see the title over there. So we try to minimize it at first, just to get, okay, sorry. Okay, dry steam schematic. Okay, dry steam schematic. Okay, previously we just see underneath the land, and then this time we just go upward on this part. Okay, geothermal zone, and then go to the turbine. Okay, in this part actually, guys, the thing that you are covered in the power plant, your power plant subject, whichever it takes, because what the geothermal is the method of supplying the hot water or the steam to the turbine, and then afterward we'll consider for the power plant activity over here, and then the remaining or the accessing steam become the water and inject it through inside the land again, and then the circulation will be continuously running, depends on the generation you are expected to produce. Okay. In your power plant, cover this one, cover this kind of basic power plant generation, cover tak? Kalau tak cover, saya pun tak tahu apa yang cover. Tapi because this one is just a very basic, very basic power plant lah, kan. We have the turbine, kan, and then they will rotate, and then the rotation will go to the shaft, and the shaft go to generator, and generator convert it to the electricity and go for the distribution, kan. At the same time, the remaining steam, and then have the condenser, and then we go to the water, and then penetrate back to the system. Okay, I think by having this kind of revision, so that's why you guys can score for power plant, because in RE also have partial of it into all the power plant. Okay, it's just the matter the source of energy to be supplied to that power plant. Okay, in this case, we are going to have the hot water from the geothermal to convert become a steam to supply in our turbine. Okay, so as simple as that. Okay, so I think this one is the storyline that's mentioned just now. Steam with water extract from the ground, pressure of initial drop, surface, and more water flash to steam. Steam separate from water. Steam drive a turbine. Turbine drive an electric generator. So as I mentioned, and generate between 5 and 100 megawatt. They use 6 to 9 times of steam per hour. Depends lah how good your system is to extract, to capture, to collect the steam, and depends on that, it may refer to your range of generated power. Okay. Okay, so far guys, any question? Or are you guys okay with this? Ke laju sangat ke, pelan sangat ke? Okay, yeah. So check to the chat box if ada, if any. So that tak ter ni lah, tak terlepas soalan lah. So check okay, PSM, assignment, cover. Okay, cover. Right. Thank you Owen for the thumbs up. Thumbs up instead. Okay lah, cover. Right. Okay, so as I mentioned guys, it depends the intention still the same. We just want to get the steam lah, of course kan, from the geothermal. It just the matter on this side, the system lah, the simplest of the system, the complexity of the system. So it up here. Okay, so we'll not touch it that detail, but just to give the idea, the intention of the geothermal to supply the steam, and then on top of it, they have a few system, want to harvest all the steam. It's just the matter how efficient the system is. Okay, maybe the previous system can collect maybe 50%, and then by having this one, maybe can collect up to the 70%. So it depends. Okay, right? Because so no, you already covered in the power plant. Okay? So then I think that particular area should be you get the idea more clear on that. Okay. Okay. So with the same approach, right? Low temperature, 100, 150, use heat to compress organic liquid, use vapor to drive a turbine as well, okay? And then typically efficiency, this one, okay? And then 0.1, 40 megawatt unit farmer, okay? So this is the case. So by the complexity of the system, normally they tend to get the better efficiency. Okay, maybe previously they maybe go for the maybe what 20%, and then by having the more complicated system, regards to enhance the efficiency, they may get up to the 25% or 30%. It depends. Okay, it depends. But the idea same or remain the same, to harvest the geothermal energy, to convert it from the earth, become the useful power. Okay, so this is the other thing. So this one, desa lah I mean, this one macam lebih, for me it's more organized lah pada desa. Sebab we have that kind of this kind of well ataupun this kind of gerudi lah kan, ataupun this kind of pipeline to get the steam. But this one we are not directly go to the turbine. We go for this heat exchanger to transfer the heat, and then this one is seems like the separate system. Yes, it's like the separate system. Okay, and then they will go the most the same, and then the accessing steam or water go inside here again, and then the circulation is happen continuously. But the big idea of this, they try to separate the system by using the heat exchanger. So we need to say this one have their own dedicated cycle, and this one also, if you can see, have their own dedicated cycle to produce the whichever the water, air and water vapor and everything. So if sales more prefer this kind of system, because if we want to trigger the failure and everything, we can try to get it in particular which kind of cycle, either the cycle, turbine cycle, in terms of the cooling tower cycle, or in terms of the geothermal cycle. So we do not have to check all over the system, because if you can see the failure and everything, then we can try to target by modular basis. We try to trigger this part first. If everything running smoothly, there's not any problem, then we can go this part here, and then after that we can go this part here. Okay, so it's a chunking of the system, which is for sure is quite good, because we can closely monitor what is the things happen, if any failure happen throughout our system based on this kind of separation of system. Okay. But the concept, I mean, the intention is still the same, to get the hot steam or hot water. Okay. Power from moderate the temperature. So this one just to get the idea, the effect, okay, the effect of your flow rate with the energy, okay, in a megawatt. Okay. So if you can see here, the greater of the mass flow rate with the high temperature may give you the highest power output. Okay, so that's a very straightforward. Okay, so this one. Okay, so this one also the same, but so just show you guys the things. Double flash power plant. Okay, similar to single operation. Unflash liquid flow to lower pressure, steam rise at second stage, increase output 20 to 50. Okay, so just the matter of the system. Okay, dapat, and then guna balik, and then dapat balik. So mungkin lah double tu means that is double lah. First stage turbine, second stage turbine kan. Dapat, guna balik, and then baru dia. So we gain the efficiency lah kan, sebab with the same resource, they try to generate 2 times by having the first stage and second stage and producing the electricity, producing the electricity via the generator. And then the remaining still goes the same to with the condenser to produce the air and water vapor via the cooling tower, cooling tower. So that's the thing. As I mentioned, it just depends on the complexity of the system, which expected to gain the better efficiency. Okay, commercial of conventional turbine technology, binary cycle technology, single family, remaining heat used to create organic vapor drive a second turbine, okay, and size ranging 10 to 100 megawatt, significantly greater efficiency, higher overall utilization, straight more power upon geothermal resource. Okay, so hot dry, okay, hot dry for this one. Okay. Well drilled 3 to 6 kilometer into crust. Okay. So into crust ni maksudnya selaput lah di bahagian earth tu. Hot crystalline rock formation, water pump into formation, water flow through the natural tissue or picking up heat, hot water steam return to surface, steam used to generate power. So this is the hot dry. So hot dry tu dia macam ni lah, more or less. So try to minimize this one. Okay, hot dry rock technology. And they try to drill all this thing, okay? And then give the water inside here, and then try to suck it back based on the system. Okay, the plan 5 years, 5 pilot of source actually always module. Okay, so this the plant, geothermal plant. Then they have the drill everything. Okay, and then 5 years refer to hot fracture rock. So they tebuk. Okay, and then dia hantar pergi air, lepas dia sedut balik air tu, then dia produce lah for the energy. Kan? So just imagine the system is lah. So that's why we need to very careful lah. Kan? Because drilling into granite baseline at 1,400. So by having all this activity, okay, and then we have that kind of container, aquifer here, and then hopefully by having that kind of water inside here, it will generate the hot water. Hopefully there's not drainage towards the area of beside the others location, and then we try to suck it back with a certain mass flow rate and generate the electricity, and the remaining water give back here, and this circulation will circulate until the long last of the production itself. Okay? Depends on the expected power generated or temperature they are required. Okay, so this is the thing: flow rate, effective HN area, accessible rock volume. Okay, accessible rock volume. So this is the new one: accessible rock volume. Okay. So You can see the title. To well HDR system parameter. Okay, right. Okay, so that's the thing. And SFR. Okay. Uh, okay. HDR, 1 kilometer cube of hot rock has the energy content. Okay, so the same approach, just the matter of the system, how they try to retrieve all the hot water inside the earth, or geothermal approach. Okay, direct use technology, geothermal heat is used directly rather than power generation. Extract heat from a low temperature geothermal resource, application site near source. Okay, so that's the thing. Okay, so it's a very straightforward. So would say it just the matter depends how complex your system is to produce to convert uh, the source of steam become the energy, because of course you already invest all the drilling activity, and you might expect that the gain should be worth lah, berbaloi lah kan, dengan all the activity or the investment that you put in place. So I think that's the reason why they go for the um, better system to get the higher efficiency, okay, with the same time of operation. Okay, so this is the thing. If you guys notice, most of the system may not go for the residential approach. They may go for the so-called have the power plant, right? To produce the electricity via the turbine application. Yeah. So it's a very rare. Let's say your guys, I mean, sir, let's say sir have a lot of money, then sir go for this drilling activity by my own. And normally it will govern by the special agency or industry, so that they will liaise with the electrical provider to supply those things, okay, to the electrical provider, and then later distribute to the public or society. Okay, depends. Okay. So, but then this the approach, geothermal heat pump, okay, heating cooling hot domestic power, hot water, ground loop, plastic pipe in a dry hole. Okay, so this the thing. So it depends. Just to mention that the temperature is slightly different according to the month. Okay, okay. At a certain time of certain condition of depth. Okay, they say um, the April, okay, April, Jan, July, October. Ground temperature typical of Northern Europe as a function of depth of different period of the year. Okay, so depends. So, but then after 10 meter depth, it more or less the same in terms of the temperature that you gain from the system. Okay? So, if you want to go with the same temperature expected, then you may go for the deeper. Okay? Maybe more than 10 meter to get the more or less similar temperature outcome based, regardless of the varies of uh, monthly basis. Okay, so this one. So item geothermal district heating system technology schematic. Okay, so this one, so we just skip it. But then again, as I mentioned, the complexity of the system just to get the better performances in terms of the geothermal activity. Okay, so we have also this kind of thing. Boiler pun ada juga. Okay, tak cukup kan? Dia top up lagi dengan boiler, perhaps heat exchanger, everything. Okay, so and then this one. Go for the residential, domestic hot water. Okay, so this is the thing. So this one, so we skip this one. Okay. Okay, so I think this one is quite interesting because it may give us the idea what is the hurdle, technically hurdle, or obstacle to be implement, or the issue that raise or concern about the geothermal power or energy. Okay, In terms of the technological issue, so this is one of it. Geothermal fluid can be corrosive. Okay? Contain gases such as hydrogen sulfide, corrosion, and scaling. So yes, because when we try to drill and get the source from underneath the earth, and then we do not know what is the so-called mineral inside there, or the details in terms of the particulars inside the earth. So it might affect to the case of the corrosion, that fluid can be corrosive. So that is the one thing we need to consider. That's why maybe in the system, more complex system, they have so-called the filtration system to ensure that we gain that kind of water or the fluid from that inside the earth become more safe due to avoid this kind of corrosive phenomenon. Okay. And then require careful selection of material and diligent operating procedure. Okay, diligent is very subjective. So would say diligent refer to the skilled worker, which is know the technical or any issue related to the operating procedure, because it more to the operational part on the top of the land, right? That power system itself. Okay, it's not relates to the case of drilling activity. We just go to the drill, and then the moment we suck all the water and everything, we will go to our system, I mean the power plant system, and then I think it refer to the operating procedure to ensure that everything running smoothly without any kind of problem which may cause the harmful or the poisonous due to the not taking care of a good operating system. Okay. And then the capacity factor, 85 to 95%, it depends. If you are running 100%, so seems like it continuously running without no stop. But then it depends. 89, 85 to 95 refer to the maybe they have to stop certain parts of operation, maybe to the maintenance and everything. But it still depends how the system targeted to produce the energy. Okay. But 95% is quite high, seems like almost running or 24/7 running. Okay. Maybe that remaining 5% during the weekend kot kan tutup kan, satu hari tutup mungkin. So that's why the 5%. Then during the daytime, I mean the weekdays, they are running 24/7 daily basis, just to capture the capacity. Okay. So hold on. Oh, sorry. Are you guys still here? I still here lah. Still there. Okay. Okay. Sedap. Alright, okay. Technology versus temperature. Alright. Technology versus temperature. Okay. This one is quite useful to get the idea what the you korang ni. Bukan fake bukan suruh adik tekan ataupun kawan sebelah tekan Right. Okay. Alright, technology versus temperature. Okay, so I think the title is quite catchy lah kan. Technology versus temperature. But then the big idea is like what is the technology offered to get the targeted temperature lah kan, in other way around in terms of the definition of the title. And then of course it should be cross in my mind the more complicated should offer us a better temperature lah kan. It's not macam lagi complicated, temperature dapat rendah aja. I think that's not the point lah. Okay, but then we will see how it goes. Okay, the reservoir temperature. If you guys have that industry that work on this particular range of temperature greater than 220 degrees C, and then reservoir fluid, it can be either form of water or steam. Okay. And normally for the high temperature, we go for the steam lah. We go for the steam lah. And then the common use is the power generation, of course. Okay. And then can be a part of the direct use. Okay. Fresh steam, combined binary that we have learned just now, direct fluid use, heat exchanger, heat pump. Okay, so this is the most technology common. And intermediate temperature, which is in the range of the 100 to 220 degrees C, reservoir fluid, water, but I think it should be can consider as well for the steam. Okay, because the power generation direct use, can binary cycle, which is more or less the same, this kind of thing. Binary cycle, this one, direct fluid use, heat exchanger, heat pump. Okay, so this is the thing. Right, and then the low temperature, I don't think this one is appropriate. I think if we go this part, 50 to 150 degrees C, for water direct use, for direct fluid use, heat exchanger, maybe we can go for the high volume now, consistent and high volume, because normally for the 50 and the 150 degrees C, for the water, we can get it in the range of the using the solar thermal. Okay? But then, if they claim they want to go for the geothermal approach, I would assume they might expect the high volume of the low temperature range. Okay, okay, and continuous running, okay. So that's the case. So using the direct fluid use and heat exchanger, okay. But then most of the technology we have been covered previously. As I mentioned, it depends on the complexity of the system to gain the better efficiency of the system. Okay, in terms of the generating the energy from the power plant. Okay, performance of geothermal terminal. Okay, availability factor 99.9. Ini tidur masa Christmas lah kot 1%, 0.1%. Okay, yang the rest ni tak adalah. Alright. Cost operation. Okay, I know produce 400 maximum load. Okay. Yes, so this is the condition of the others country, okay, because we do not have any data for our country, of course. But then just to get the idea performance of typical geothermal power plant, which is relatively high. But then, as I mentioned, they need to configure that source of energy based on the location, the surrounding, and everything to make sure that can be disseminated evenly to the others. If not, there's a multiple problem will be occur due to that kind of activity, which is not solved. You solve the one issue, but you are create several issue, another several issue, which is not good. Okay, we try to go that way. Okay, so install capacity 16 megawatt. Maximum load 55, annual 462, house operation 8,000, load factor 90 something. It's considerably good, yeah, good, what is that? A good selection of having the geothermal. Okay. So called the equivalent, the equivalent for this. All right. So again, next, we go for the part which might be interesting. The environmental implication. Okay. Can you guys or someone guess at first? Okay? What is your expected environmental implication when we are going to do the geothermal activity? You may jot down in the chat box, and at the same time, we have a break for 5 minutes. Okay, guys, boleh? Okay, okay, okay. Siapa yang tunjuk good tu saya tak tanya. Yang tak tunjuk good nanti saya tanya. Boleh tak? Okay, saya tak tanya lah. Saya dah buat good. Woi, semua. Oh, boy, semua. Boleh rekod tak siapa yang buat good, siapa yang tak buat good ni? Yes, kita break 5 minutes. Then you can get a cup of coffee and everything. Later, so ni lah, kita sambung lah. 5 minute break. Hello guys. So okay, we shall proceed. Okay. So check first is that banyak lagi ke slide nak cover. If not, we will continue for the next following class. Okay, we already cover half of it. So I think maybe we can go another 9, another 30 minutes lah kan? 30 minutes, okay. After this, you guys ada kelas kan? So, you guys sekarang ni ada dekat fakulti lah kan? Betul kan? Oh, kat rumah. So, nanti kelas petang ni macam mana? Online juga? Sekejap, saya baca je ya. Apa ni? Petang cancel club. Oh, lagi baik daripada saya. Petang cancel. Itulah. Semua tunjuk good je kat saya. Okay, 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 okay. So, saya ingatkan saya dah baik ya. Rupanya ada lecturer lagi baik daripada saya. Bagus, bagus, bagus. Bagus, bagus. Tapi sebenarnya macam ni okey lah kot kan? So, at least kita tak payah nak ganti kelas kan? Kan? So, itulah. Kalau nak cari kelas nanti susah kan? Semua nak cari masa. So, kita gunakan masa yang ada lah. Kita make use of it and fully utilize of it. Right? So, shall we start? Yeah, yeah, agree, sir. Sir, okay, okay. Thank you, Pak. Okay. Okay, so next. Maybe we can try to cover the next 20 minutes lah, the remaining slide regarding the geothermal. And later, if sir reach that time, someone of you can try to ping sir. Sir, masa habis. Kita lah macam tu. Okay? So takut nanti kan sir tak perasan kan. Okay? So next, environmental application. I think yes, we must know the environmental application. But then maybe that is not that crucial for us because we are the country not using the geothermal, right? But then just good to have the knowledge of this so that we know even we are blessed not having that kind of geothermal, I mean the volcanic area in our country. But then it's in place we also has been avoid by having this kind of environmental implication if we are going to do the geothermal power source. Okay, so let's see this together. Okay, it can be divided. It is more relates to the environmental case specifically for the land, water, air, ground. Okay, so of course, if you want to go for that, as I mentioned, when we are decided to go for the RE specifically for the geothermal, so we need to scan through where is the suitable places, right? And let's say that suitable places is the area fully equipped or fully have that kind of greenery, plantation and everything. So we don't have the option. We need to clean or clear that particular area to so-called install our geothermal facility to do the drilling activity, etc. So by having that kind of condition, so we may sacrifice our land in terms of the vegetation, kan? And then by having that kind of the drilling activity, it might occur to the potential of the soil erosion, and also in the case of the currently the landslide. Yes, okay, lupa. So those who have the relative or friends or whoever family somewhere in Batang Kali affected by that landslide, so I mean, in our class, convey the condolence to them. Okay, and I think maybe we can have the 3 minutes to sedekahkan Al-Fatihah for the keluarga mangsa lah. Okay, Al-Fatihah. Bismillahirrahmanirrahim. Ya, silakan. Amin, amin, Rabbil alamin. Okay, so because what, guys, for the case of the Batang Kali itu kan, so ya lah. Itu yang kita tak ada buat apa-apa aktiviti yang geothermal kan. So you just imagine kan, kalau that particular potential area is somewhere over there, and then we also doing the activity that, let's say, want to install the thing and everything. So the potential to have that kind of landslide, it might be multiple chances, right? So which is yalah, yes, we can say we can have the good foundation and everything, but then actually it relates to the case of the groundwork punya condition kan. Dalam tanah tu kan, we can't see, do not know what is the condition, so that there's a big question for us to assure the case of that thing secure enough for that kind of activity. Okay. And then in terms of the air, alright, so the air, udara bukan air ya. Air ni water, ni air lah, udara. Slight air heating, local fogging. Yalah, by removing all the greenery plantation and tree and everything. So it seems like you are moving out the shaded area, which is slightly air heating, quite a local fogging. So in balance of the air circulation, yeah, and the ground, reservoir cooling, seismicity, tremors, yeah. So this one. Can someone check for sir what's the tremors, seismicity? Can someone check for sir? And later put in the chat box. This one, seismicity. Sebab dia punya term ni macam power sangat ni. Padahal macam sepatutnya bahasa dia mudah je ni. Yeah. Alright. While waiting for the definition of the tremors or seismicity, so we go for the water, okay, in terms of the environmental part, watershed impact, the mainstream, okay, hydrothermal eruption, lower water table, subsidence, okay. And then of course, by having the activity, depends, this one is depends, the noise, okay. Noise means that yalah, based on that drilling activity lah, kan. Kan, okay, thank you Aiman. So nama seismicity kan sebenarnya earthquake je, kan. So earthquake means that in terms of the condition of the land and that particular area, I would say, kan, kita dah drill, kan, and then it might have the potential of that, kan. Dia macam kita lubang-lubangkan tanah kita lah kan. Betul. Alright, and noise, okay. Noise ni quite subjective actually, because most of the residential may stay apart, away from the power plant, kan. But then I think the noise to refer to the case of that activity create a noise at least to the workers lah, kan, which is stay inside in the power plant and nearby. Okay, not noise for the residential, because normally the residential may stay away. I mean, the area, it should be not that particular area, but then it refers to the case of the worker itself. Okay, meaning overall, so the integration of this problem. Okay, all right. Okay, so this one, renewable, heat depleted as a ground cool, not steady state. Earth's core does not replenish heat to crust quickly enough. Okay, so this is the another issue or concern. When we see about the renewable, it should be the thing is replenish. So we see the replenish. Replenish ni in bahasa replenish. So someone check replenish. Replenish. Eja dia je. Because what? When we do the drilling and then we capture all the hot parts to get the steam and hot water. Yes, that kind seems like the free source from the middle center of the earth. But then actually the issue of the renewable take place to the drilling activity. Kan? After we try to break the wall brick, okay, the debris inside the earth. So it might not be formed just next 2 days or 3 days, right? That rock kan. So kita dah pecahkan that batu untuk kita penetrate until the certain level of depth to get the hot condition to hot our steam, I mean the water. But then the brick itself is not recover, right? We just so-called macam tebuk lah kan. So that's the other way around in terms of the definition of the RE kan. We get the things, I mean we get the hot from the center of earth, but at the same time we so-called demolish the rock which is inside the earth to get it kan. So that's the another question we need to consider when we go for the RE sources. Okay. A score do not replenish ni, replenish. Betul, replenish. Apa? Ada tak apa? Replenish. Ya, refill. Boleh lah. Replenish. Okay. Not refill. Refill. Thank you. Siapa ni bagi ni? Okay. Fina. Thank you, Fina. Ya, replenish. So, itu macam kita dah tebuk atau pecahkan batu-batu tu kan untuk kita buat that pipeline. So yelah, we got the free energy from the earth tu, I mean the center of the earth, but at the same time kita dah pecah-pecahkan batu-batu yang for the 1,000 years perhaps they created underground our land kan. So that's the thing lah, that's the thing, which is dia punya foundation tu become weaken lah kan, akan lagi lemah lah sebab kita dah pecah-pecah kan, dah jadi pecah. So maybe lah dia reflect to the case of the apa tadi tu yang definition tu, formal level or condition. Okay. Earthquake tadi tu kan, earthquake, seismicity. Economics of geothermal. Okay, so that one is the consideration of the environmental impact, and this one maybe, so we think this is the, ke nak stop tak? Ke macam kita stop lah kan? Stop lah sikit boleh lah, yang banyak lagi. Dia sambung ni kan terpaksa habis kan. Okay lah, kita stop. Kita nanti ingatkan saya, kita stop dekat economics geothermal. Economics geothermal Kita stop sharing. Alright. So guys, thank you very much for your attention. So I think today we stop until that part. So hopefully by having this kind of online session, you may get the better view of focusing that particular slide instead of the class. Those who are sit at the background, at the back, not very clear. Otherwise, you have the slide on your phone, right, on your tablet. There should be no problem. So now we have 66 participants, which is 13. Sorry, berapa? 3, 15, 10, 13, 10, 8, 7 orang, 7 student missing. Okay, hopefully the missing refer to the case of the good health, it's not admitted to hospital or something. Okay, with that guys, I thank you very much. Thanks for your time. See you guys later on this Thursday, inshallah. With that, thank you. Have a good rest, those who are at the hometown, and all the best. Okay, see you guys later.
Thank you, sir.
Okay, welcome. Oh, baru dengar suara. Okay, so stop record.
Thank you, sir. Thank you,
Okay,
sir.
stop record. Okay.
Thank you, sir. Thank you, sir.